Vice President Research and Enterprise, Professor Mark Spearing, who is going to introduce our guest lecturer. Thank you.
Thank you very much, Wendy. And just a couple of minutes of introduction. I was asked to do two things. So it's a great pleasure to welcome you all in person, and there are a good number of you here, and also those online to this annual Regius Professor Lecture in Computer Science. I was asked to do two things, one of which was to provide a bit of context and to follow on what Wendy said, explain a little bit about what a Regius Professorship is and why we have one in computer science at Southampton. And the second thing to do, it would be my pleasure to introduce Tom, this year's lecturer. So, what you need to know, a little bit of Latin and a little bit of history. Regius Professor, Regius literally means the monarch, the king's professor in computer science. The first of these was established by James IV of Scotland at the University of Aberdeen in the area of medicine or physique or something like that in 1497. And for the next 500 years, 7 so-called ancient universities in the UK and Ireland were the sole hosts of Regius chairs, and there were a couple of dozen of them spread around different disciplines of theology or divinity, I think was, and classics and so forth. But in 2013, to commemorate the late Queen's Diamond Jubilee, there was a call which resulted in 12 new Regius professorships, Regius chairs being established. It was a very competitive process, and we here at Southampton were absolutely delighted that we were awarded a Regius chair in computer science to reflect the strength of our research and teaching in the area of computer science. So what are we good at in computer science? Well, it goes back to 1967. The Department of Computation, Professor David Barron, established it here, and it has always been, unlike some other computing science departments, been very close to electronics as a discipline, which was established here by Professor Zeppler in about 1947, immediately, and a particular strength in computation. And so some of the things that computer science itself, and in 1986, electronics and computer science were merged, and have stayed merged as the School of Electronics and Computer Science to this day. And particularly, notably, was strong at that interface between hardware and software. But things like early work in hypermedia, which is I think where Wendy cut her spurs, also in some of the seminal work in agent-based methods, and also a very strong commitment to open access and our ePrints platform, which I think is used by about 600 different institutions worldwide to this day. And we were the first institution to have an institution-wide mandate for the open access of our research. And Kirk's there nodding wisely. So we'll have many credentials, and we're delighted to have a Regius chair in computer science, of which, as Wendy has announced, she is the current, in fact only the second holder thereof. And that brings us on, as part of this chair, we have committed to having an annual lecture. And so it is a really great pleasure to introduce Professor Tom Rodden, who I've known for quite a few years, and many in this room will have known for a lot longer. He's been a very good friend to many of us at the University of Southampton and colleague for a number of years. Tom is a very distinguished computer scientist. He's been at the University of Nottingham for a bit over 20 years, and prior to that he was at the University of Lancaster. He's done a spell working with our colleague Phil Nelson as the Deputy Executive Chair of the Engineering and Physical Sciences Research Council, and then subsequent to that he did a 4-year stint from 2019 to 2023 as the Chief Scientific Advisor at the Department of Culture, Media and Sport. And you will notice that that time period is significant because it was right through the middle of COVID. So Tom led and provided scientific leadership on all those difficult things about whether to hold events or not in the DCMS remit, as well as some of the computer science IT solutions that might apply. Back in his own territory, and we'll hear about this in his talk, Tom is, of course, a distinguished computer scientist, and particularly working at the interface between the social sciences and computer science. He's a fellow of the Royal Academy of Engineering, but he's also a fellow of the Academy of Social Sciences as well as the Association of Computing Machinery and the British Computer Society. So he's got all the honours and awards, but his real expertise has been at that interface between social sciences and computer science. And that interdisciplinarity, I think, is something that resonates particularly well for us here at Southampton. So without further ado, looking at the title in front of me, which I think is a wonderful title, From Esoteric Endeavour to Economic Driver, we very much look forward to hearing from Tom, this year's Regius Professor Lecturer. Tom, over to you.
Good evening, everybody. So, thank you very much. It's always great that people turn out. You always worry that doesn't happen. 1967, you must be one of the oldest computing departments around here. Yeah. So, which is part of what I want to talk about. So, there comes a point in your life. There are many moments of change. You have children. You go to university. But there is the moment when you give a talk, which is a retrospective on your discipline. And you know, at that moment, you're heading towards the exit door. Okay? So what I'm going to try and do, I'm going to do a little bit of a retrospective. I'll mention some of the work that I've done within it, but more broad than that. And what I'm really interested in talking through is the way in which computing has actually changed from my initial engagement with it to now. So obviously, through that period, lots have changed. So I want to start, though, by showing a video of Arthur C. Clarke in 1974 talking about computing. So it's a really interesting video in a couple of ways. I mean, I think first of all is the kind of foresight to talk about societal interactions, to talk about personal computers, talk about things. A couple of things to observe there, one of which was, God, the use of men was interesting in there, wasn't it? It was a businessman. But it was very much focused on work and thinking about work. And we'll talk about how that changes over time. But the other thing to probably say that was this, at this moment, seemed sensible. At the moment when he was saying it, and any of us here who were involved in the early days of computing, people just didn't believe you. They didn't think that was the future. So it was a kind of much more small scale, much more esoteric, much less impactful feeling discipline. There was lots of issues at that moment in time. So what I want to do is talk about that change in nature. I want to talk about how it's changed quite radically in the UK as to what counts as a computer scientist and who does computing, kind of how the discipline has shifted and changes, the techniques that I've involved if we've changed that. I want to talk a little bit about research and a little bit of research in UK universities, and then I finally want to talk about the kind of economic power that we now see within computing. So I'm going to draw there upon the work I did as a CSA when I was at the kind of Department of Digital Culture, Media and Sport. So now I'm going to embarrass my colleagues at Nottingham, okay? So I'm going to actually, first computers, come on, what did you have?
ZX81.
Good man, exactly the answer I wanted. So you were not alone. So here's all my colleagues talking about what happened with them and
My
ZX.
childhood is the first two words that come into mind. When I was one of those nerd kids in the 80s who spent all their time in a darkened bedroom hacking away on games.
Jetpack. There was my misspent youth playing Jetpack over, I can't remember, somewhere 84, 85, something like that.
Probably C5. The beauty of them was that you could understand the entire computer, you could understand the entire computer, the operating system, the basic language that was built in, and so on.
The best time I ever had as a computer scientist was when I was programming the Spectrum, age 16 or 17.
Loading screens, failed loading, turning tapes over, banging them all.
Okay. So for some of the people in the room, that will have brought back fond memories. For many in the room, it will feel like a strange and unusual world before the internet, which, believe me, was invented. It was not given to us by God, despite a number of people occasionally feeling this. So what I'm going to do is I'm going to use work that... So as a computer scientist, I'm particularly interested on interfaces. I'm particularly interested in how you interact with these devices and how you work through them. So I'm going to build upon work by Jonathan Gruden, where he talks about the computer reaching out and how over a period of time it's changed and what computing is and the focus of computing has changed. So let's start at the kind of early days of computing, the simple days of the ZX spectrum, the ZX or Motorola microcodes, etc. So this is where the focus was on computation, with the computer and computation, predominantly a combination, as we heard, of electronic engineering and computer scientists. The focus was on high-level abstractions, operating systems, computer systems, data structure and storage, algorithms, techniques, all the stuff that nobody else, other than if you were a computer scientist, you'd understand, or that you'd see. So you had this dominance of a particular set of disciplines. The focus on assessment and testing at this time was predominantly on hardware and software. So it was about a particularly narrow perspective from what came to. So it was a small community of practice, and there was a small number of people who effectively sold computing to the world. This was when, at a time when the internet looked a bit like this.
Yep, Peter Kirsten.
Yeah. So this is UCL, Peter Kirsten. And those of you of a particular age will remember coloured book communications. This is the protocols before the internet agreed that there was a common set of protocols. And back in those days, this was a familiar sound. Oops. Oh, God. And it was as dodgy as this as well. Let's go back. Let's do that. Let's try. Okay, so the internet wasn't the ubiquitous thing it is here. There was a rawness of the engineering and a rawness of what was happening here. Okay, it was a world that we all understood in a particular way. So, and it sounded as bad as that, didn't it? And it would always stop at that point. So very quickly though, the focus started to change, and it started to think about graphical interfaces particularly. Okay, the kind of Macintosh interface and others. So graphics and presentation now became the focus of computing. The computation, the languages were less of a focus of what was happening in the kind of research at this point in time. So it was all about metaphors for interaction, drag and drop, pointing, how you assess this, novel interactive devices such as the mouse and the keyboard, again, and that kind of graphics. So at that point, the disciplines involved in computing started to grow. We saw more people from a human factors background, more work in graphic design, more cognitive psychology, more links with psychology departments. So computing had moved already from that simple set of disciplines, hardly simple, but that core set of disciplines, and broadened. So they focus on assessment then became ease of use, understandability, kind of legibility. And at that point, you started to see a shift also in the social perceptions of computing. Okay, so those of you, so you went from these command-line interfaces, you know, and then you had, you know, what I like to refer to as the advert in 1984. Now, that was an advert of its time, many problems with it, and we can unpack lots of issues with that. But the things to kind of highlight, there's one of them is, that is the first kind of start of computing has been referred to less as computational machines, but more as tools, things for the general. So it's entering public consciousness, it's entering culture, the kind of cultural things as well. It also stays deeply within the tradition of computer science, which has gone back all the way to Babbage, is if we can oversell, we oversell. Okay? And again, another feature you will see as we go through that. So at this point, we have a range of disciplines that are looking at building intuitive interfaces, looking at the nature of those interfaces and thinking through them. So again, the computer reaches out a little bit more. So as we go through into the kind of 1990s, we know the actual device itself becomes replaced with an emphasis on what's the device for, what's the world of work. So it focuses on the individual, the task that the person's doing. You're seeing people talk about office automation, task decompositions, expert systems to aid in diagnosis. So a growth in user modeling, application domains, and a focus on the individual. So at this point, what we're really interested in is how the things in people's brains match the things in the computer and how you help them do those sorts of things. So we're looking very much at focus on the world of the individual and how to make these things more sensible. So, you know, yeah, so we've been at the game now 20 odd years, and so I just want to quickly show you a bit of a newscast from 1995, which shows you what the big problem in computing was then.
Computers are supposed to make life easier. About 1 in 3 American households has fought that theory and purchased a PC. But what they didn't tell you is that life does not get easier right away. For many newcomers, PC stands for pain and confusion. Lee Taylor reports.
Jamie Gold is about to buy her first computer. She hardly knows where to start. She's the kind of customer that is turning the industry upside down.
What is the 4 megabyte memory versus
Home PC sales are now exceeding business sales, up 25% last year and still accelerating. Jamie Gold spent $2,800 buying into the sales pitch that computers are now easy to use.
This is the world's easiest personal computer.
It makes you powerful. I just think I want to plug it in first and use it.
But it's still not just another household appliance.
Installation disc number 1. I don't know which the interface cable is. The hell is a power module? I'm not done. Hold on. There's nothing that looks like this. I don't hear it.
Jamie is gridlocked with plenty of company.
It's printing way too large, and I don't know why.
For years, phone and help centers were used by technically inclined.
So it's good to know we've solved that problem. Okay. and we've left that one behind. The things to take from that insight is computing is now in the home. It's starting to be domesticated. The users are not professional users, and the ways in which they use it are not professional. So the need to think through that has started to emerge and start to be seen. But but then, so this is when I kind of initial bits of my research started at this point. So this was when, at this point, the dominant thinking was around the individual and the role of the individual and the individual's interaction with technology. So there was a significant shift that took place through the 1990s in research to think of computing more about collaboration and cooperation and how you support people. Now, there was a couple of reasons for this, one of which, not the least of which, was the emergence of wide-scale network interconnectivity, the emergence of web and web technologies amongst those, and the emphasis now becomes less about what programming languages, networking infrastructures, or the role of the individual, but more about the workplace and efficiency in the workplace. So working together, coordination. We saw an increase in communication tools, both audio and video as well, and distributed shared information became an increasingly important part of what we did. So lots of the work here at Southampton focused on how people would share that information, what ontologies would be developed, and how we would work through this. So considerable work. So at this point, I find myself in my career working with ethnographers, working with social scientists, with anthropologists who seek to understand the nature of social interaction and social endeavours and how those work. And the focus is less now on the technology, but much more on the work setting, much more on how you think about the digital workplace. So to give you some examples of this now, so the kinds of things that we saw was looking at air traffic control in the UK, understanding the nature of air traffic control and understanding how you would computerise that system. So there's quite a lot of work we did with LATSI looking specifically at this. Some early work, this is Bill Buxton, but it's early work on video spaces. Now those of you who were around at the time, so Xerox Europark in Cambridge took a building and they wired the building with 20 or 30 kilometres of coaxial cable and analogue video switches to mimic the ability for people to have instant video connections to each of the offices that were there. This is long before you could, now we just use Zoom, right? But what was happening at that point was understanding what the interaction would be, understanding how people would use this. And a more recent example, which is what we did with Abigail Sterling at Microsoft Research, this is using a Connect box and using the gestures in the Connect box to do interaction for surgical manipulation. So the surgeon here is using the gesture recognition in order to be able to drive the software that's there. Why are they doing that? It's a really simple, practical reason. These things are bloody dirty. Okay? Putting them into a surgical setting is a really dumb thing to do. And when you actually go and look at do studies of surgeons working with them, you'll see the most amazing and elaborate wrapping of these to make them surgically secure, which is why the gesture-based interaction can happen. So the setting becomes really important, understanding the setting. So I want to kind of continue in that vein and talk a little bit about the work we did predominantly within what we did in Equator 20 odd years ago now. So this is the next shift, and there's two kind of parallel shifts that I want to talk about for modern computing. One of which is into the world we inhabit. How many screens have we got here? How many devices are there kicking around? But, so devices are now carried and worn. So we've got these, we carry them, we wear them. Location becomes much more important. Sensors become much more important. Communication and computation is built into the world. And then we also see values that are less about efficiency, less about work, and more about the rest of our lives. Okay, be it domestic settings, be it domestic, be it art, be it entertainment. So, and a growing emphasis already starting on social media. Okay, so we're seeing the growth of that and working through that. So at that point, the people who add and join the kind of collection of people you would think of as computer scientists, now start to use design, so Royal College of Art, design of product design, nature, all those arts and entertainment, and are added to these disciplines. And as Phil and I can attest, boy, did they all get funded. So what you would think of as a funder as computing is a really big grouping of people and a really big grouping of disciplines. And that actually is an interesting thing for us all as the identity of what we think of as computing. So the focus now, entertainment, living things, much broader kind of set of adaptations. So the kinds of things here, and again, this 20 years ago, are children using this for educational purposes out in the wild, looking at how to measure things and look at things within a woodland setting to understand ecology. Guides to help in museums, so that your location-based sensing are those within museums. A selection of work that we did on fairground rides, looking at how you would capture physiological reactions on fairground rides and productize them. So we worked with Alton Towers, and we looked at people wearing galvanic skin resistance and small cameras, and actually selling that as a souvenir of the ride. Okay, and working through how those would be in terms of productization. I want to show you probably one of the most iconic bits of work that we did within this. So this is a piece of work that is interesting for a number of reasons, not the least of which is it won best papers in most HCI venues, in some computational venues, but it also won major arts prizes, including a Golden Nika from Ars Electronica. So Can You See Me Now toured 40 odd cities across the globe and was run out of them. What things to highlight there, notice how much tech we had to strap on to people with a GPS receiver, a PDA, all of the things which you now take for granted. And 15 years later, Pokemon Go type entertainment emerges. So one of the things to say here is in computing, that 20-year rule still holds. It takes a period of time before the things that we think of as being immediately there are actually there in the world for globally. But again, I want to go now to the other trend that, as well as computing, reaching and being embedded in the world we have, it backing away and going into the cloud. And an emphasis here on scale and scale of resources and large-scale resources. And this is one that we've seen over the last 10 or 15 years become really quite a prominent thing. So data and compute centres start to emerge. The power of large volumes of collected data and the analysis start to emerge. Large-scale compute and analytical insights for a range of products and a range of different domains, which is based upon population insights, start to emerge. And we're seeing an increasing use of data. So now we're starting to see a return, in a sense, to some of the kind of core statistics, algorithms and data techniques, and them scaled up, reinvented and reused. So the interesting thing here is the growing importance of the value of data and computation across it. And that notion of two things, scale and a concentration of that, should say, resources. And I think that's quite an important thing, and I'll talk a little bit more about why that's important, as a small set of people now have access and ability to do research. So computing has changed, okay? And that's the first message. So I want to just summarise that kind of computing change by showing you two slides, okay? So this is from the ACM Curriculum and Computing. So this is the 1982 paper and the curriculum. And so this is what a computing degree was. Okay? You do, computer systems and concepts, programs, data management, modelling, decision-making, systems development projects. You might do some information analysis alongside it. So that was that's computing 1982. Okay? 2001, this is the same syllabus, and this is just the knowledge topics within the syllabuses. So to show you the kind of size and scale and diversification within computing. So that's why that's important, is how that's actually happened within the UK and how that's impacted within research. For my previous sins and multiple previous lives, I've been on 4 RA and REF panels, every one painful, and every one a true demonstration of the power of episodic memory. Okay, so you forget how painful they are, and then you just do it again. Okay, again, I think Phil's been a chair of one of these as well, and so what you've seen as you've tried to assess UK computing is that growing set of disciplines. So you start to see art, you start to see practice-based research, you start to see ethnography, qualitative research methods, quantitative research methods. That interdisciplinarity grows, but it grows in a really interesting way. And I think this is something about computing that's probably worth saying. It grows in an interesting way, not necessarily in working with another department or working across the university. You find that the people return to you, embedded within computing departments, are social scientists or designers or artists, but they've found a home within a modern computing department. There's a massive growth in the impact of research. Okay, so at the last, at the most recent REF, when we were thinking about how to deal with impact case studies, a chair from another discipline said, well, obviously, if you've spun out a company and it's capitalised at 2 or 3 million, that's a 4-star growth. At which point you're going, well, yeah, in computing you're talking 600 or 700 million at capitalisation towards a 4. I mean, the scale and size, you're talking about billions of users, so you have to calibrate in a slightly different way, but you really do see the importance and the impact. And you see a growing emphasis on use-driven research across computing as well. So as well as the abstract, as well as the more abstract, theoretical or focused computing problems, you see a large number of medical-driven research. You see a large growth in those areas. So you get this broader perspective on computing. So over those years, we've seen a few things. We've seen a growth in numbers. So in 2001, there was 1,200 researchers returned in terms of to the REF. In 2021, there were 3,000. There was still roughly 90 to 100 research establishments returning. Lots of mixed methods. We actually saw even some unicorn companies returned in the last one. So we saw capitalizations at the billion. So computing from this esoteric kind of thing that had how do you legitimize yourself and are you a real discipline, suddenly is a massive economic heavyweight. And you see a kind of changing set of fashions. You see e-science being replaced with data science, replaced with various forms of AI. And just to kind of close that off a little bit, here's some Excel spreadsheet playing. So these are the returns that happened over 2008, 2014, 2021. So what I've done here is I've taken the GPA scores of each unit and I've sorted them. So you're seeing the pattern. And the things to notice here is year on year, that uplift in GPA, and actually year on year, a flattening of that curve as well. So take the heads and tails away, and you actually see the range in discrimination. So some of this is a feature of the methodology, but it's also a feature of the strength and breadth of strength in the UK of computing science and computer science research. Across all our institutions, there is excellent computer science out there, and lots of people doing that. So let's kind of transition now to think about computing in a slightly different way. So I want to think about computing as an economic power. So I was appointed as the first CSA in the Department of Digital Culture, Media and Sport. So that was the first time the UK had given a digital remit to a government department. Okay, and there's a whole backstory as to why it ended up with DCMS. Not the least of which is they didn't have to change any acronyms. Not the least of which. That's a better story. It's a better reason than the actual ones. So why is that important? Well, let's have a look. So this is the 20 top 20 top companies by capitalisation. So let's watch what happens over time. Oil industry, still doing well. So in that 20-year period, we end up with the top set of companies being all in the digital and computing space. These are what's called the GAFAM companies: Google, Amazon, Facebook, Apple, and Microsoft. Okay, so that's driving the world economy. All right. So while I might have enjoyed the start of my life thinking about, what was it? He said some of his happiest moments were when he was 16 and just writing some code. The world economy is on the shoulders of computing now. It's quite a shift, and quite a significant shift. Okay? And it's become really quite pointed over the last 4 or 5 years. And I think this is the point of doing the journey up to now it's been about the discipline, it's been about the nature of the discipline, and it's been driven and owned by the discipline. This is an interesting inflection point where the world economy and the UK economy now starts to think about economic growth, and computing is a key element of this. So 3 years ago, the National Committee for Science and Technology was created as part of understanding the integrated review. So the UK government launched the Science and Technology Framework, which is an interesting moment, because what it actually says within that is that the future growth of the UK will be predicated on science and the UK being a science and technology superpower. Of the 5 kind of technologies mentioned, 4 of them are predominantly computing and digital. So we get an increasing need to think about regulation, governance, and how those. So the growing emphasis also on how you maximise the opportunity and you reduce the harms of these technologies. So final thing to say on that is, if those of you who can't read, this image is generated using AI. Inspire. We'll talk a little more of that later. So Why does this impact you as a researcher? So let's look at the first one. First one is security. Okay. Alongside that, we saw the National Security and Investment Act. National Security Investment Act now says that there are particular technologies which are controlled in particular ways. Of the 17 areas mentioned, 8 of them are directly computing, and most of the others are supported by computer science. So this has major implications for the practice of research. So how you do research, who you can research with, and what you can do in research is now significantly governed. So funders such as UKRI now are accountable for use, dual use and misuse. Okay? So those of you who think about this, there's 2 parts of this, the one of which is a movement of IP, the other of which is security. Moving data counts as an export. Okay? So when you go and look, you see that a number of computer scientists and how they do research might well be breaking UK export law. Okay? So we're now, it's now not that cosy, esoteric endeavour it once was. It's now massively important to national security and what you can do. The other thing that grew over this period is the regulation of online activities. You know, the online safety bill, which was 5 or 6 years in the cooking, finally gained royal assent. And so there's a kind of, it's a challenging environment in terms of regulation, in terms of how you think through regulation. So how do you balance between expression and design these to not have harm? So this is where you really do rub up against the big GAFAM companies, the Facebooks, Microsofts. How do you think about regulation? How do you support regulation in this space? Now, it's actually made hard from a technical perspective, and I just want to pause for a second and show you one of the examples I had to deal with while I was a CSA. So, although I've talked about those kind of phases and focuses as being linear over time, actually abstraction and the way computer science constructs things, they're layered on top of each other, and they each have a different frequency of change. So in particular, you'll find that the infrastructure and the core protocols of the internet are really hard to change. Are really hard to change and only change it very infrequently. But there's a greater speed of change and ability to change as you go through that stack. So this is based on Brandt's notion of layered diagrams. So the economic activity, this massive economic activity, is kind of the combination of the Internet of Things, emerging new technologies, and all those cloud infrastructures. Okay, but they're predicated on an infrastructure which hasn't changed much since the 1970s, and that causes actual problems. And so one of the things that, as an example of that causing a problem, is a protocol change called DOH, or DNS over HTTP. Okay, computer scientists still, we can make an acronym out of acronyms. So one of the big issues with DNS, for those of you familiar with it, is that it's pretty much unchanged since 1983. It's still open text, or predominantly open text, and it's open to the person in the middle attack. So encrypting it seems like a very good idea. So what happened was that the standards bodies decided to approve DOH as a particular way of doing it. Now there are technical issues and technical problems here, which is it mixes the control plane and the data plane on the internet, which is never a good idea anyway, but it encrypts the DNS request and places it inside data packets so that nobody can see it. Big problem for regulation now. So DNS has been used for the last 20 years as a kind of government in the middle. It's the point of intercept to in place certain things. So it is used for blocking access. So what happens to block access to a site is it's removed from the DNS entries. Okay? ISPs use it to default and family filtering. so that you can have default family filtering on at your ISP, so that you can remove certain sites. It's used also to detect malware and intercept malware, and it's also used as part of the Investigatory Powers Act in the UK. So when a number of GAFAM companies decide that they're going to adopt DOH and they're going to roll it out and roll it out to the UK population in the next 4 months, and you remove all of this, you have a real problem. So this didn't happen. There's a few interesting conversations where this didn't happen, which I was involved in. But one of the reasons was that the way in which computer science and the internet community thought about standards was to think only of the protocol, not of its use, not of its implications of use. And it still doesn't think that way. So it's a really interesting thing about governance, standards, and how we do these things in a broadly responsible way. So that is a kind of worked example of the devil in the detail. To make this, just to make you aware of the strangeness of the thing. Not only that, but the actual two acts actually use DNS, mention DNS and ISPs in the regulation and in the government and the Act of Parliament. So given that, so baking in the name of a protocol and baking in a function. So let's then talk about AI in government. So as I was towards the kind of final part, you will have seen an awful lot of noise on AI in government. So, and it's changed changing in ways that were really quite weird, to be honest. So we had an AI national AI strategy. I still think it's out there somewhere. They still talk about it. And that national AI strategy is really interesting. It is worth reading. It's well constructed. It talks about people at the centre of AI, talks about equity, talks about transparency. And the AI Council, which Wendy was involved with, drove that and worked through that. And the challenges as to what, when and how to regulate in the AI space. And actually, I'd also commend to you the DCMS, DCIT, discussion paper on AI regulation, which talks about regulating within sectors and outside sectors. Then a strange thing happened. Focus suddenly emerged and started to talk about harms and the existential threat of harms in the future. But actually, I think the real issue is the harms that the AI does now, the lack of transparency, the misappropriated use of it, the lack of accountability. All of these harms are here and now, and really, really important. And there's a focus on this. I mean, these are great. This is a fantastic screenshot for us as a discipline, but maybe they're looking at the wrong problem. Maybe they're thinking about the wrong thing, and they're thinking about harm and that harm's to come. Now, I just want to end by that notion of harm and that notion of threat. So, it's not a new notion for us in computing. Far from it. So, in the 80s, they were all going to take our jobs. Office workers, robots after a job, honeymoon with robots will end. Okay? But it's okay, because in the 1990s, it was still there. It was going to, it was crime in a workless society. End of work. All, that massive, big existential threat. Computing was going to do this to us. And it persisted into the 2000s. So this is, legislation of internet piracy will ruin, Napster will destroy music. If you remember those of you of an age will remember that. So that's, again, not a new one. And just to keep us up to date, it's still. So the rhetoric here is really rather interesting. The rhetoric is of harm. But actually, harm is just the other side of impact. So it's about how you think through that harm and how you work through that thing. So I think the focus for the future of computing is on that responsibility. Okay, how we think about and how we work and engage across disciplines to think about those economic and political drivers, to think about those societal drivers, and how we innovate in computing responsibly. So I think the next decade or so of computing, the disciplines and focus that will be driving large parts of our research agenda will be how to accrue the benefits while avoiding those harms. So designing responsible solutions, responsible approaches, and making the technology designed to allow regulation rather than having regulation chase that technology. And then I think the final kind of thing I want to actually say is I have used throughout this talk the word computing, and I'm going to keep using the word computing. There is a real danger that it all becomes AI, and all we talk about is AI. And to use a kind of quote from Muffy Calder on this, oh, you just mean clever computing again. Because that's actually what it is for us. But out there, it's something magic, something special, but we understand the algorithms, as a discipline. Conversations I have in our house, because my wife's also a computer scientist, about some of the claims about LLMs. But that's not how probabilistic networks work. So I think there is going to be a kind of destination for computing to become less visible over the next decade as well. Less about the big bang of AI, more about the heavy lifting of economics and the heavy lifting of kind of moving society forward. So I'll stop at that point and invite questions.
So, questions from the room, and then maybe something online. And Tim, at school these days.
So the way computing is evolving, particularly at the higher levels, is very rapid. But the legislation is very, very slow. I was just wondering how we fit those together.
Well, I think there's two things to say here. I think people do say that, but actually the technology may change, but the fundamental nature of what's been legislated doesn't necessarily change at quite the same pace. So one of the things I'd actually spent quite a bit of time talking to policy people about was is just because they say computing or AI doesn't make it different. So what is the issue? So actually most of the legislation in online harms is about governance. It's about good governance. It's about making your executives have a responsible person. It's about giving people the right of complaint. It's about giving people rights of inspection. So those are rights that are easily movable from existing areas in the existing sectors. So there is a sense by which actually, in some ways, much of the digital issues in the digital can be solved by just applying UK law as it currently exists and doing that mapping. What's been interesting in the last 5 to 6 years is the policy people have been really learning curve about the nature of the technology and then what it means in terms of how you regulate it. So I think there is definitely what you have to do though is future-proof. You don't bake in a particular protocol. So those of you who from the comms world, EU got itself all in a mess over Bluetooth because they listed communication protocols and forgot, and Bluetooth was then invented and it wasn't covered by legislation and they had to go back and do things. So you have to future-proof in certain ways. But I think part of the challenge I'll give to computer science is just make the technology easier to govern. Actually make it part of your design criteria. How do you govern this? How do you make it accountable? How do you present the traffic that's there in a way that allows regulation without causing breaches in privacy? I mean, these are all design criteria that we can design the technology to make it easier to regulate as well.
More questions in the room?
I'll ask you a question which is a bit socially rather than engineering, which I hope you may be able to answer. The first one is around the fact that we, as engineers, scientists, should be aiming to provide services to society. So all computing, everything that we do should be for society. So I'll ask you a question around the digital divide, which nobody seemed to address, and all these money-making machines that we need to think about. And also, do you think that current technologies will allow us to overcome this? And if we, in our next generation, will also still have this digital divide persisting?
So I think left unchecked, left without regulation, left without intervention by government and by us as scientists, and without an emphasis on responsible innovation, that divide will get worse. It will exacerbate. Okay, and you know, I'll give you as an example of what we saw play out through COVID was the digital's role in education and exacerbating a terrible divide. So those kids who had laptops versus those kids who didn't. We've just recently banned mobile phones from school classrooms, yet that might be the only device within a household. So I think there is a need for us to explicitly look at this and to make it about a driver about public good and the nature of public good. And I think this is a role where universities speak strongest. Okay? There's enough tech boys out there that will build lots of gee whiz things. Universities will incubate and will do things that they won't do. And that will involve access to communities that don't have access to this or do things. We're in a very strange space in the UK. So nobody in the UK is mandated to have a digital identity except for one population. You cannot receive benefits in the UK without having a UK digital identity. Okay? So the only people in the UK mandated effectively to have a digital identity are those who are in receipt of benefits. So I think there's already built into the system these divisions and divides, and I think part of what we want to do is surface those and work through those. And you'll see this amplify, I mean, Gopal, you know, in the work that Gopal, you know, insurance levels will change, credit ratings will change, and targeted healthcare will change. So Glasgow City I come from, that the gradient of life expectancy across Glasgow is 20 years from west to east in terms of life expectancy. So there really is a challenge here as more of that gets automated and less of it becomes invisible, that it happens without people being held to account, which is why I think the focus of the future has to be on embracing that responsibility and designing for it.
What they are investigating computer science with regards to the recent developments on AI, the mixed reality models. Personally, I think we create all this technology join the society and then think about implications and regulations.
Yeah.
So what do you think is the social impacts with respect to what they are trying to go? It is all great in terms of science, technology, but there is also social...
So I think I'll do kind of a couple of reflections on that, right? One of which is the earlier the engagement, the better. Okay, so we are, you know, we are occasionally a community with a solution looking for a problem. We get seduced by being able to do new, novel things. Engage in social science, engage in understandings of people and their needs earlier in that process can effectively reshape that. So you do so you engage and involve. It's interesting. So it's interesting that, and I think some of this gets down to some of our practices. So it's interesting that in the medical domain, you wouldn't necessarily get a research protocol agreed without an explicit statement as to how it's shaped by users and shaped by patients and users and others. Our level of maturity in research is rather interesting. So if you think about things like open science, We don't do open science within computing and engineering. We don't pre-publish our protocols in quite the same way. We don't say what it is we're going to do and who we're going to engage with. So I think there's a range of our practices which can be altered to kind of co-create and co-shape those technologies with society rather than impose them on society and then try and do a repair. So I think that'd be probably my strongest kind of reflection, because I think there is a real dilemma of this, gee whiz, and throw it out and see what happens.
Now I think I have to apologise, I'm sitting there because I'm not here, I have to apologise to our online folk. We didn't specify we wanted guests to be able to ask questions, so only Southampton people can ask questions online, but less over there you've been asking people to tweet. And we do have a question from someone you might know.
Yes, I've got a question from Professor Tom Crick, who's your successor at DCMS CSA. He says, please, can I have all the budget codes? And then there's a follow-up question, which, shall I tell him no?
Yeah, well, I'll explain the budget codes in a second.
Right. There's a follow-up question. In the style of a popular university debate, does this House believe that the widespread reach and impact of digital data, cyber tech on society, culture and the economy has been positive for the perception and standing of the academic discipline of computer science? And in particular, the wider understanding of what computer science actually is compared to other more established academic disciplines.
Right, I'm going to work through these questions. First of all, the codes. He's got a budget. I didn't have one. Ask Jasmine and Nicole. They will know where the budget codes are. Right, is my advice to them, the people that they're working with. Yep. So ask him. So now, what was it? The rest of stuff. Yeah, no, the House believes. So, I think I'm going to do, and I'm going to teach. So, by the way, big piece of advice always given to me is hire someone better than your replacement. So Tom is my replacement. But I'm now going to teach him about sloping shoulder civil service answers. Okay? How to avoid answering that question. Actually, I think it's a bit of both. And I think there are benefits to us as a discipline. I've highlighted them in terms of our importance. There are risks in that exposure, and I've highlighted some of the kind of constraints that are there. The one thing I've not actually talked about that he touches on, because he talks about data and data analytics, is the issues in and around the concentration of power. And I think there are fundamental challenges for us as a discipline in the concentration of power, both in terms of data centres and how you would do systems work in data centres. For the last 15 years or so, everybody who submits to SIGCON, the big communications and big networking conferences, if you work with Microsoft and have access to Azure, or if you work with Google and have access to their cloud infrastructure, you can do research that no one else in the community can do. Okay? So suddenly we now have a kind of perception that the hot stuff and the important stuff in research is in those tech companies, not in the universities. Okay? Similarly with data and access to data. So that leads us to really interesting things. I mean, we were talking earlier with Wendy about open sovereign capability for something like an LLM. Where would you do this and how could you do that in the UK at that size and scale? Now there are investments that have been made. So the upgrade to the replacement for Archer is going to be as near a dam at an exascale machine. There's an investment in Bristol with a large scale of NVIDIA machines. But it feels like an arms race. And one of the things for us to worry about as a discipline, I would argue, is that government hears an increasing message that the hot action is in those tech companies, not here. Now, the hot action is in those tech companies because they think about it in a 4-year timescale. And having worked in a research lab like Microsoft, the minute your shareholders decide you're not doing that, you're not doing it. So the longer term, fundamental, 20-year research to imagine a future world is the remit of us as universities and the remit of funders in the UK. And UK traditionally, over many, many years, have been excellent at funding that kind of research. The dual track model of funding that we do and the nature of the funding that has been issued has allowed the UK to have a lead in areas such as those. For example, do you think anybody other than EPSRC were supporting deep neural networks 20 years ago? Okay, and funding. Not very little in the US, very little. But the point being, it wasn't the industry that was doing it. It wasn't that was a bonkers idea that would never work until it worked. Okay, and I think that's part of the debate that needs to kind of happen in decent.
We were talking earlier about will there be another AI winter. Les, you've got another one, I know.
I've got a question from Professor Andy.
Yeah.
I've got a question from Professor Andy Wright, who's...
Oh, yes.
You also know.
Who I also know.
Yeah, who's at Glasgow, is an enterprise professorial fellow here. And he asks, what do you think the UK will be recognised for in the area of computing in 10 to 15 years? Just an easy one.
So the answer to that question is closely linked with me owning a yacht, if I knew the answer. I think it will still be known for what it's known for now, and I think its strengths will still be there. One of the things about computing in the UK is its collegiality and its collaborations across multiple sites. You contrast that with the US, which is much more competitive and a stronger kind of interdisciplinary links within it. So that will persist. So I think I would hope that within the world of AI, a more balanced approach and a more nuanced kind of approach, looking there, particularly at responsible AI. I think there will be major algorithmic insights in the UK, because that's one of the key strengths of the UK as well, the number of people who work within those domains and work through those domains. So I think that those would be kind of key strengths that I would actually see within it. I think it's unlikely to be... So research and computing is going to be more tactical and more specific. So I think research and computing, which is based upon brute force, is not where the UK will play or should play. I think it's, because we can't afford it. And actually have bright ideas is a much better tactic than buy a bigger machine anyway. So I think those are the kind of places I'd see.
You've got one more?
I've got one more from a PhD student, Wan Saifuddin, who is, he says, as the world becomes increasingly interconnected, international collaboration and information sharing have become more critical than ever, especially in the rapidly evolving field of AI. How is the UK working to facilitate international collaboration and knowledge sharing in the field of AI research and development?
So I think there's 2 or 3 things in there. So I think the UK, much of the discussion around the AI Summit, much of the discussion about data adequacy and links to data are about appropriateness of sharing. There are fundamental kind of issues here. So one of the dilemmas for the UK, as it is for the US, for Canada and for Australia, is what partners there are, how you share, and what that sharing actually means. So I still think we have to work through that whole kind of process of trusted research in terms of how that sharing actually takes place. And I think there are a number of people thinking through how to do this, but it's really quite challenging, particularly given that large amounts of that data are not in the public domain, are not controlled by government. They're controlled by public corporations, corporations and global corporations. So I think there's going to be a really interesting debate over the next 4 or 5 years about what actually happens with that.
So 2 hands go up, and then we'll have to. Oh, yeah, maybe we have to call it a day soon. Simon. Come to you next.
If you had the power to change whatever policy you wanted, given that sort of unilateral power,
Ah, fantastic.
what would you change within universities to gain more impact from you?
So if I had a policy to change in universities, give them more money. They're skint. I mean, seriously, if there's a single policy, we're in a very strange position, a very precarious position, HEIs in the UK. I think it's really interesting debate as to whether the policy in and around REF needs to change and whether we promote different styles and types of research. I think the direction of travel in REF at present is confusing. And I thought that's as near as diplomatic I'm going to get, or brackets bonkers. There are many things that I'm willing to compete with Southampton on. Research culture doesn't feel like it should be one of them, right? It really shouldn't. And so there is a really interesting thing about the drivers there of kind of innovation. So I think value to the S&T. I think the S&T framework's really good, and I think following that through, because it talks about using procurement to drive innovation. It talks about infrastructure being stable and longer. So there's quite a lot of reasonably good written policies in that S&T framework. So a part of me would be, could we just do it? Please.
Thank you, Wendy. Thank you for showing how much more we have to teach now compared to a few years ago. So, and there is only so much we can fit in 3 years before.
Yep.
So what do you think we should be teaching our students?
So I think we're very much into a kind of set of T-shaped types of people. So I think for some of this it's about awareness. So I think you will have specific specialisms in there and within it. I think there's a challenge that I kind of briefly mentioned in the slide but didn't talk through. Actually, I think computing has a intradisciplinary challenge, which, as opposed to interdisciplinary, in that there are a number of communities that focus on particular sets of things and how they then talk to each other. So I think each of our degree courses have particular types and sets of specialisms. So I would hope that we can teach the people who have deep knowledge of statistics needed for AI, actually have an awareness of culture and people alongside it, and the people that are doing the evaluation assessment and user experience part of it actually understand a bit more about what the technology actually does and don't think of it as an immutable object that can't be modified and can't be changed. So I think some of it's about connecting together the different bits of specialisms that we'd have in each of our courses.
Right, I'm going to wind it. I've got a last question.
Oh,
that's easy. Can we train an LLM to do the next ref?
Actually, I think we probably could, but more worryingly, can we train an LLM to spot LLMs generated publications submitted to the next ref as well? So I think if I want to complete, I think ref has done its job. I think before the REE and before ref, the general model in UK was to say how great we were, but never write anything, or do. So now we've got vibrant kind of energy going into publication and vibrant energy going into impact. I think we are definitely in the world of diminishing return. I think if you look at the results from the last ref, you got increases. You increase the scores, but you reduce the discrimination across the sector. So it feels to me that in some ways REF has kind of done the scores. It is amazing when I have to explain to international colleagues, so you do what? Well, 20 of us all get together once every 7 years and we all kind of look at and score about 2,000 papers, and then we agree how to do that. And they're going, why? So it can be automated.
Every single paper we had to do.
Yes, it can. So I would argue it can be automated and it can be done. What's really worrying about it is all of the data to train those models got destroyed at the end of the last ref. Okay.
We tried to get them to do a shadow exercise
Yep.
with the data before it was
Yeah.
destroyed, but they didn't. Anyway,
Yeah.
we can talk about this as well. I'm now going to ask the school, Tim Norman, to give the vote of thanks. Thank you, Tim.
So firstly, thank you, Tom, for your talk. It's really insightful. I certainly had a load of memories coming through from that. Thank you for attending here, and all of those who've joined us online. As Wendy said, this is the second.
Yes, it should have been before Christmas, but I haven't.
Absolutely, but this is a really important tradition
So this
for
is
us
the
as
second-
ECS.
We're a year late. But
Yeah, we have our Christmas lecture and our Regius lecture, and these sorts of events are really important in terms of bringing us together as a community and reaching out to the broader community that we serve. And I see some students here as well, which is even better. Excellent. So again, we have refreshments and downstairs? Or?
No, they're here.
Oh, they're here. Okay, so I'm not going to
tea, coffee.
Cause any more delays. Again, thank you very much, Tom, for that fantastic talk.
Thank you, Tom.